Long ago, in the faraway land of ancient Greece, there was a golden age of powerful gods and extraordinary heroes.
Listen to him. He's making the story sound like some Greek tragedy.
Lighten up, dude.
We'll take it from here, darling.
You go, girl.
The Greeks, other than believing their gods lived on top of a very climbable hill and never bothering to check, were obsessed with reason and rationality. Consider Greek architecture. Every picture of every ruin you've ever seen has been symmetrical, even, and balanced. These attributes reflect the thinking of the Greeks in the ancient world. Pythagoras is one of the best examples of these kinds of thinkers. He was a mathematician and a philosopher all rolled into one, and his followers formed a cult which was simultaneously political, religious, and philosophical. They believed that numbers are the key to the universe. Their fourfold curriculum was based on number theory, geometry, music, and astronomy. The idea of harmonia says that parts make up the whole. Math creates the building blocks and relationships of the different elements of the universe. Rules like a circle is bisected by its diameter, the sides of similar triangles are proportional, or the base angles of an isosceles triangle are congruent, may have been known, at least on some level, before the Pythagoreans came along. But the Greeks were the first to look at math for math's sake and to collect these seemingly disparate rules into one discipline. On that note, the legend of the harmonious blacksmith says, once upon a time there was a blacksmith hard at work in the middle of Greece. As he hit and shaped the metal into tools and artwork and whatever else he had to work on, he hit each piece with the hammer appropriate for the task at hand. Each hammer produced different kinds of sounds, and the blacksmith liked the different sounds. He enjoyed the pitches and the way they sounded together. Sometimes he would hold a hammer in each hand and alternate, enjoying the music it made. One morning, Pythagoras happened upon the smithy, drawn in by the rough but enthused music. Being an analytical mind, Pythagoras looked for patterns between the sounds that seemed most pleasant to his ear. The blacksmith, happy to have some company, told him he was free to investigate in his shop, and before long, Pythagoras was examining hammers, weighing their heads, and comparing pitches. He found that there were specific ratios that always produced to the same intervals, and the simplest ratios, 2 to 1, 3 to 2, 4 to 3, produced the most harmonious intervals. This must have been especially encouraging to the Pythagoreans, since the cardinal numbers 1 through 4 already had special significance for their group. These numbers actually form the tetractys, to which they swore their oaths. This story is just a legend. It's uncertain whether Pythagoras actually discovered these ratios in a blacksmith shop. But he and his Greeks and their weird obsession with math discovered as a group that mathematical ratios are a formative aspect of creating music. Just as two hammerheads, one twice the size of the other, will produce an octave, a string twice the length of another will produce the same pitch, one octave lower. In terms of sound waves, A4 sounds at 440 cycles per second, while the next octave down sounds at 220 cycles per second. These ratios permeate the whole experience of creating music, and there are more complicated ratios that we use today to create minor thirds, major seconds, sixths, and sevenths. Tritones are produced by the ratio the square root of 2 to 1, which seems appropriate considering it's been called the devil's interval for many years. And so it is. Although mathematicians and musicians seem to feel frequently at odds, as if the study of one discipline must take away from another, the Greeks showed us that both exist as a critical part of the whole. The ratios that create musical intervals were critical to them the same way pi, the ratio obtained by dividing a circle's circumference by its diameter, was critical to them. These ratios don't change no matter how big the circle, no matter how low the note. The universe is made of both music and math, and contributing citizens will spend time in the devoted study of both.